Well, hello, y'all. Welcome back again to another edition, another step into Brian's bus adventure. This week, we're going to be doing something a little bit different. It's not going to be out in the bus. It's going to be for the bus, but it's not going to be in the bus yet. We will be installing it, of course, real quick. And I am talking about getting into the electronics a little bit. And, okay, there's a lid. Here's what I'm going to be doing here. I am going to be doing a fuse block. This is a relay block, relays and fuses. And the reason we're going to be doing this is because I don't know what, oh, I just learned this. And so I think it's very important, but I just learned that it's very important. Can I say that? It's important to be important? Yeah. Okay. It's important that we protect the electrical leads going to, or I should say from the switches back to the product that's being serviced by that switch, be it a light, a turn signal, whatever, a fan, anything like that. I just learned this last week that if you don't use a relay to control the electricity, that you can really overload a line very easily. You can overload the line, or you can overload the switch itself, because you're putting a lot of juice down a switch that really doesn't need to go down a switch. Yeah, that makes sense. These relays allow you to turn on a switch, let's say a headlight switch or even a brake switch, anything like that. Send that juice down the electrical line, and if it goes straight to the stoplight, then all that juice, all 24 volts in this case, are going down the entire line. And again, we've got a 35-foot bus here, so it looks like the drop could be, well, probably considerable, but also the amperage could be high by the time it gets there. It could be just really, juicing out, so to speak. But what this does is it'll let that juice from that switch come down the line, and it will activate this at about 0.7 amps. 0.7 amps, that's nothing. That's really nothing. And then, because we do have a hotline coming from a source, in this case it'll be directly from the battery, to this via, hang on, let me get something else here. Got to get all the stuff together for you, I guess, first. But we're going to be using these fuse blocks, or these electrical blocks. And what this will do is this, and this will be backed by the battery, by the way, even though the switch for the, and I'm going to continue to use the term, the headlights. The switch that you step on for the headlights, yeah, in our case, it's the old style switches like you had in the old days. Step on it with your foot. The electricity will come directly from the battery, and it'll be hot lead all the way down through here, and the hot leads from that will be going to this. And this, indeed, will get a surge of power as soon as it's activated by that light switch, or by that power lead coming down from that light switch. It'll activate this, and then this relay will trip at about 0.7 amps. Then it will send the entire 24 volts from our power lead from the battery, and not from the switch, but from now it's coming from the battery, because we've wired it into this, and we've sent a signal to this relay to operate that light, whichever it is. It's going to be a turn signal, a stop light, a flasher, a reverse light, a headlight. It could be any type of lights. We'll just use lights just as an example here, but it could be anything. I have a big fan also back in the rear end of the bus that I'm going to be fusing in also, so it doesn't pull a lot of amperage down the line. But again, this will let it, just a small little trickle, like 7 amps, 0.7 amps, excuse me, activate this switch, and then this will in turn take that juice from the battery, directly from the battery, the 24 volts, which is only, like 5 feet away. It'll take that entire 24 volts and send that to that light, that desired light, the turn signal, the stop light, the reverse light, the park lights, the headlights, the whatever light you're looking at. So that's what we're going to be doing today. We're going to be taking this and rewiring it. And as you can see, I have wired part of it up together already. I haven't put the major lead from this over to these yet, because you have to feed each individual circuit with 24 volts. And each one of these will go to a different relay. And it's going to be the same thing on the negative side. Each of these, the black wire here, if you can see it through my shirt there. Let's see. Yeah, there you go. There are black wires or ground wires coming from each of these relays also. And I'm going to take the time in just a few minutes to explain to you all about how a relay works and what happens when you do and or don't use a relay. Okay, y'all, I'm back, and now I'm going to show you a drawing, and I do mean this is quite a drawing. It's not quite what I would consider to be a perfect drawing or even close, but it is what I have out here, and it's what I'm going to show you. So this looks like Mr. Magoo. Well, if you remember who Mr. Magoo was, or is, I guess he still is. Yeah, anyway, this is kind of something like he would have drawn, but I'm going to turn this over and let you look at this. Okay, I hope you can see that. And this is what the front of a relay or the back of the relay, the pins of the relay will look like when you're looking at them. And you'll see there's 5. In this case, there are 5 pins on this. Normally, the relays that you will be using do not have this 5th one in the center, and you don't need that. You need a 4-pin for just about everything. You can use a 5-pin. It's called like a high-low beam switch or something you could use for headlights, but I'm not even going to do that. I'm still going to use a single relay for the low beams and a single relay for the high beams. But this is what it looks like when you look at one. And here's the numerical way that this thing is addressed. And again, this is something I think they did in Germany years and years ago, and who knows why they numbered it this way. But again, if you look at this pin, if you look at the pins, these are kind of the way they're drawn out here. And like I showed you a while ago, I have the red wires coming here and the black wires coming here. So the only thing that I have that's actually wired on this relay at the present time is the positive power. This will be the 24 volts from whatever source you have. Again, I'm taking it from the battery. And if you do use a battery, make sure you use about a 30 or 35 amp circuit breaker in this before it gets to these relays, just in case something happens. It's like a redundant safety factor in there. But what I have wired right now is number 30. Number 30 will always be the power, and that will be here. And they're numbered on there. You can't quite see it, but there are numbers on there. And this is number 30. They're the same as right here, and it's wired for the power coming in to the relay. Simple as that. Then we're going to jump out of over here because we know that we have to have power going out of a relay also. So you're going to go over here to number 85, which is this one here, and it's the ground. That would be the black wire, and that will go, again, if you remember, I had something here. I had these little switches or these little relay box posts here, what do you want to call it? But again, this would be power coming from this over to the 30, going over to 85, and then being grounded back over here to the chassis. And make sure you have a good, like a 10 gauge wire coming from the battery, and also a 10 gauge wire going to the ground also. That really gets it kind of foolproof safety factor there. It's not going to melt out on you. And then, okay, what are the other switch relays here on this thing for? Okay, once the power is in here, it's going to go, okay, now what do I do? Where do I go? And as soon as you hit that switch, it's going to activate a little coil inside here, which is inside of this, and it'll throw juice, or when you activate this, it'll throw juice from this up to 87, which is going to whatever you want to light up. I'm going to call it the lights. But then, and that's all there is to it, really. Power in, power to the switch, power to the light. Simple as that. But that little relay, it's like a coil inside there, and it takes that necessary amount of electricity and keeps it constant. It's a nice heavy flow of 24 volts in this case, and we'll send it over to the light. Again, positive number 30, ground number 85, from the switch, from your headlight switch, number 36, and then over to the light, number 87. And that really is all there is to this whole puppy. I hope you kind of got that, because it's really kind of simple. But again, make sure, put my glasses down. There we go. Can you not see? There you can see my eyes. Anyway, it's really simple. Oh, you don't want to see my pistolas back there, do you? Some people don't. I don't care. Anyway, it's really kind of a simple process when you look at it. But that will really, really, really make your lighting system kind of fail-proof, safe, you know, like they said in the old days. Well, I guess fail-proof is not fail-proof, but it'll really help the wiring, and it'll help you have a constant voltage going to the lights. Because at the end of a 35 or a 40 or 45-foot bus, or even a schoolie, when you hit that switch up on the dash and send that juice clear to the back of the bus or back of whatever you have, it's going to drop. the voltage will drop. And sometimes if the wiring's not the best in the world back there, or going to from the switch back to the back of the bus for your stoplights, if there's a challenge, corrosion, whatever, you're not going to get the full voltage back there, and you'll have some dim lights. So again, that's all we're going to be doing this week as we look at, oops, I don't want to get guns in there again. Anyway, as we look at these, and we're going to install all of these, and each one of these will go to a different source, or from a different source, actually from the same source, the same ground, but they'll be going, each of them, to a different light in the back of the bus, and also back to that big fan. And how am I going to mount it? I have this plastic little cube here, and that's going to go like this. Let me show you what this is. Boom. Let me get everything together here before I do it. Turn this back around. This is what it's going to mount up on. You have the positive coming in from the battery, negative on this side, negative going to a good ground to make sure when you're doing a ground that you scrape all the paint off and get it down to bare metal so you do have a good ground. And then each of these, the remainder of them, there'll be a switch in, and there will be an out to the lights. Simple, simple, simple. And you will be getting good connections you should say you'll be getting good voltage to whatever part you're trying to get a voltage to. Again, in my case, it's going to be taillights, stoplights, turn signals, hazard lights, and a fan, an extra cooling fan on the radiator in the back of this 4108A. That's a Greyhound bus, of course, a Buffalo. But again, that's what I'm going to be doing this week, and I'm going to be throwing this up so you can see this so far, and then I'm going to be coming back a little bit later and show you the entire process of how you wire this, how you mount this up in the bus, and how you make your lights work correctly. I hope you enjoyed it. And again, this is the Brian's Bus Adventure, and I hope you like what we're doing this week as we kind of go through different processes here with the Brian's Bus Adventure. Something else we've been doing, as you see, I have brand new flooring in my house. That's been installed this last week, which is really nice. The wife is kind of happy on that one, I guarantee that. But anyway, this is the Brian's Bus Adventure. Don't forget to like, share, and subscribe to it. And if you'd like to help us out with, like $5 or $10 a month, that would be greatly appreciated on our Patreon. That's patreon.com/Brian's Bus Adventure. And that would help us out a whole lot so we can get this thing on the road and get down the road in the not too distant future. It's been a lot more work than we thought, but it's a labor of love. And again, this is the Brian's Bus Adventure. Y'all have a great week. We'll talk to you real soon.